So, let's see here. So we're gonna talk about 3D printing, okay? And go to the table of contents here. Right here, that's us tonight. Okay, now, I have some good news and some bad news. The bad news is that there are 294 slides in this deck. Okay, if you think you've been through some HR presentations that were bad and long, this is worse. But we're not gonna look at all 294 slides. Okay, we're gonna jump around a little bit and do some things like that. So, and at the end of each one of these sections, we're gonna have a slide that's gonna pop up like that. It's like a section marker in the book. And we'll pause, if you have any questions, we'll work on it. And if you don't, we'll take it from there. Now, what I've got up here, okay, is I have some 3D printed parts I've done. Some are just pretty generic, and some are pretty neat. And I'll show those to you when the time comes. So here we go. All right, so, okay, this is me. Okay, I'm a mechanical engineer. I've been doing electronic packaging for about 25 years. Worked on the Abrams M1, A2 tank on the night vision optical system, fire control system, SATCOM systems, spectrometers, all kinds of stuff, right? And I love what I do. I have some insights in my shielding design as a mechanical engineer. I've done a lot of design and manufacturing for assembly. I'm a Honeywell, Aerospace, Six Sigma 3. Wow. Oh yeah. A lot of CAD experience. I've got about 12,000 hours in SolidWorks, 5,000 hours in Pro E. I've been doing it for a long time. I talked to people about 3D printing. Talked to my wife, but I had to stop because she got tired. And
You have a restroom just outside.
working on 2 books. The first one is called Cog Shell Spacecraft Design and Electronic Packaging for Mechanical Engineers using SolidWorks. And the reason the title is so long is when people go out to Amazon and type in Cog Shell. Oops, go back. There we go. If they type in Cog Shell, if they type in spacecraft, if they type in electronic packaging, if they type in mechanical engineering, if they type in SolidWorks, my book will come up. So, I've also, a long time ago, beginning of my career, I worked for Parker Hannifin and designed valves and stuff. I did 12 years of night school, hard way. That was the first job out of school, right? So I've done some writing. I know about hydraulic and systems and stuff. So, let's, the next slide. This is just stuff I've designed. This is just, you know, you guys would probably recognize this. This is a vehicle-mounted RF SATCOM system. This is a SATCOM system enclosed, electronic enclosure. It's actually this box right here. Work for Ocean Optics doing spectrometers and stuff right here. Electronic packaging, I worked for SATCOM systems with TCS for about 4 years before they went to Orlando. And just electronic systems. I do structural analysis, temperature analysis, thermal analysis on boxes and stuff. But this here is my pride and joy. This is the book that's gonna get finished this year. You can see there's that really long title right there, okay? And what it is, it's, the subtitle is, it's a system design perspective for 21st century mechanical engineers. It's a 1-semester college course. I want to teach at USF, St. Pete College. I think this book should be taught at every university in the country where they're doing engineering. Because what it does, I mean, let's think back when we all started out on this stuff, way back when. And we're sitting in a design review, and somebody says, okay, we've got circuit cards, are we gonna conformal code those cards? Or do we have to worry about EMI 461? Or do we have to worry about, you know, mill standard 810 for a temperature range in North Africa. Most of us, that we just got out of school, we wouldn't have any idea what anybody was talking about. That's what this book does. It walks people past ITAR, conformal coding, and because it's primarily for mechanical engineers, it has a couple of really good chapters on what is the circuit card, what's the ground plane, what are PIAs, what are traces, you know, just stuff that you guys know all about. So, I'm really excited about it. It's gonna get published this year. So, let's see, the next slide, that's the valve book I wrote. I wrote it, illustrated it. You know, valves are just valves. They're probably like, they're the equivalent of capacitors. Every capacitor that's ever been designed has been designed. Same thing with valves. That's why I'm not doing valves anymore. So, time for a little break. I've got some business cards up here. Me. The front and then the back has got a summary, my resume on the back. And if in your, I'm currently looking for new opportunities. Is that what they tell you in HR?
Yes.
So, in your travels, if you guys are in a project, or you know somebody who's got a project, and we need a good mechanical engineer who come in here, who actually understands this stuff, and can land the airplane the first time, give me a call, maybe I can help you out. So, here we go. So, I spent 18 months at US SOCOM at the UTV facility covering SAP. UTV stands for user.
No, I did not.
Don't worry about it.
I'm on. There we go. Look at it. User test bed, okay? And what they did there was a good bit of it was classified, a good bit of it was not classified. We worked for a SOCOM organization called PEO CERSI, which I think is Systems Reconnaissance, Electronics, and things like that. We're familiar with CERSI. Have you heard of CERSI?
Mm-mm.
You? Okay, well, they're a number one of the, there's a lot of different PEO organizations out of SOCOM, and we work for CERSI, SRSE. And, so, that's where we're located. It's over there by Jade, in that neck of the woods. Right over here is Tampa Microwave. Up here is a company called Cobasat. Y'all have probably driven by it a bunch of times as you're going over the Howard Franklin Bridge, right? St. Pete. All right, so when I got there, there was a there was a 3D printer in the back of the in the back lab. It was in a great big lab area. They had electroplating equipment, you know, drill presses, all kinds of stuff back there. And the place was a wreck. It really was. And I saw this. The 3D printer was one of the biggest ones I've ever seen before. Okay, it was huge. It was. Let me think. It was as long as this table. It was this high off the ground. You'll see pictures of it. This high off the ground, and it was about here to this other table. It was huge, and it was a fantastic 3D printer. They weren't really taking care of it, and so what I did over the next 6 or 8 months was I took this whole area, cleaned up the lab, got the floors buffed and everything else, and made it look shipshape. And because my intention was to have a bunch of majors and captains, folks like that, colonels come through on tours and things like that, and they would take a look at all the things we had done for 3D printing and say, can you make me one of these? And I would say, yes, sir, I can. I would say, all I need to know is how big do you want this? And they would say, well, we want it to be 18 by 18 by 8. And I would say, well, it'll take about 3 days to go do it, and we'll do it for you. And unfortunately, I don't know, the way SOCOM is set up, it's like all these tables in the room here. You have PEO CERSI, and then you have PEO fixed wing, and then you got PEO maritime and PEO whatever, right? They don't share money. They don't talk to each other. In fact, This just occurred to me, they're kinda like the five families up in this world, right? I'll leave it at that. Great bunch of people, but they don't talk to each other, so my mission, to try to sell these different organizations and what we could do for them, it didn't work, but it was a lot of fun. So, here we go, so I'm gonna show you some pictures of what we did. This plaque here, this plate was the exact size of our printing area, okay? It was 19 by 15 by 7 3/4 inches tall. That was our printing volume. And this is a rough representation of the Sunshine Skyway Bridge, right? And it said, the bridge of excellence for client mission success, right? And we had electrical engineers, mechanical engineers, RF, microwave, SATCOM, software, all that stuff. Because I was in a marketing mode, right? And actually, SOCOM, I don't know, that's just not the hat they wear. So, it took me about 6 months to learn. But this is some of the stuff we did. Now, this is the drone. This is what we call the Italian drone. I downloaded this thing off the internet. Okay, and actually, the Italian drone right here, I'm gonna pass this around, with the exception of the text that I added to this thing in SolidWorks on the top and on the bottom is this drone. And this was the most elegant, the best piece we ever made out there. We had material that you use, resin and stuff for 3D printing. It was expired, so I just took about $2,000 worth of expired material, printed.
Interesting question. So that, I mean, that's a great looking piece of plastic. You know, with your 3D printer, did it sort of like print it from the ground up, or did you print different parts and stick them together, or?
The ground up. Now, I'm gonna pass this around. All I ask is you be very careful, because the legs are they're worse than matchsticks, okay? But take a look at the writing on the bottom and everything else. Now, here's the thing about this drone that we printed up. This is unmachinable. You can never machine this thing. You could put it on a 4-axis CNC. You get a block of aluminum or a block of anything, nylon, right, and start trying to cut this thing out. It could be done. What it would cost, I don't know, maybe $10,000 for the machine time. And that's assuming you've got a good programmer and the machine's stable and sturdy and everything else. The beauty of 3D printing is that, and you'll see this later on, is that it's not just that you can have a prototype that you can take to a design review and show people what it's gonna look like. That's nice, all right, people do that. But what you can do for flight and field hardware is you can create designs that are totally different from anything you've ever done before. What I liked about this drone, right, is if you take a look at the legs, right, it looks like something from a sci-fi movie, right? It's not like, you know, it's almost like it's an insect or something, right? And what you can do is you can optimize your design mechanically with respect to stress and weight, and center of gravity, and all these different things. I mean, they're just incredible things you can do with this.
Thank you.
This is why they're using 3D printing for metals to do rocket engines now. And a titanium, stainless steel, things like that. It's just the most incredible thing. But it's not the silver bullet though. And that's something that, you know, I don't know. Go ahead, sir.
I hope you're gonna tell us at some point how you create the, I'll call it ink, that makes metal stuff.
You buy it.
Well, how does somebody make it? I'm curious about that.
I don't know.
Tell me later, I'm just.
I'll do my best. I'll do my best. But, so, there you go. Now, someone asked, I think, about, okay, what did this look like when we were making it? Well, different types of 3D printing, there are different types of processes, okay? Like welding and carpentry, they're just completely different. We used a resin-based system, and what you see here, this is actually that part, or the part you just saw, okay? On the table of the printer, after it was printed, it took about, I don't know, it took about 20 hours for this thing to print. Wow. And the yellow stuff is what we call support material. So all the spaces and gaps and stuff you see in this drone right here, for example, you see this top shelf here? And then the shelf down below, it was all full of support material, because as it's printing layer by layer by layer, it says, okay, I'm gonna print the legs and all that as it moves up. It prints this bottom shelf down here, and the software knows it's gotta put support material all in this middle section here, so when it comes up here to do the top and print the top plastic, it has something to print it on. Because
Oh, wow.
it can't print in air. I mean, it can't just like, right here, it can't do that. It has to print on a surface like that. So, and then you clean it off in a high pressure spray machine and whatnot. It takes a while, depending on the part. But that's how this works. So, the great thing about the 3D printer we had was it was resin based. We could print all kinds of stuff. We printed ABS and all kinds of stuff, and unlike most of the 3D printers you see at Best Buy and anywhere else really, right? We could print rubber.
Oh, wow.
Right? Now, he's gonna take a look at that piece. When a program manager comes to you and says, okay, we wanna design a portable electronics device, right, for the field. And we wanna have a rubber keypad. Okay? We wanna have a rubber keypad inside this gun. One of the questions the mechanical engineer will ask is, well, what's the durometer? How hard does the rubber have to be? I mean, when you go push the buttons, well, what do you want it to be like? Most mechanical engineers don't, I mean, they understand what durometer is, but they've never really tested. So the bottom line is, what I did was I created 6 different test panels, just like this.
Oh, wow.
I actually gave them all their own part number, and as you can see on here, the one that's going around, and I'll send this one around too, it actually says this is 60 durometer. I think the other one's 40 durometer.
What's that word you're using?
Durometer.
Never heard that word.
Yes, sir. Well,
Measurement of force.
it's kinda like the line, right? Okay, so,
That's cool.
but the bottom line though is that, so you're asking a PM or your team, how hard should the buttons be? You just hand them one of these panels, and there were 6 they could choose from, and they could say, well, we like this one right here. And I would say, well, okay, that's 80 durometer, and that's what we use. And that's what our printer could go do. Like I said, I used to talk to my wife about this, and she just got tired. But, so all these different materials, it was just great. So, all right, one more thing. This is what you can do 3D printing for, use it for. This enclosure right here was designed when I worked for TCS over in Brandon. We were building SATCOM systems. We built 2 of these enclosures. They were prototypes. And all they were supposed to go do was we were gonna take all the circuit cards and cables and SASM modules and GPS modules, install them all in there, hook up all the cables, right? And make sure they can make dish turn on the satellite and on the antenna and grab the satellite. That's all we wanted to go do. It was a fit check. We spent $8,000 on each box.
Thank you.
We could have printed on the machine at SOCOM, we could have printed that box right there in 3 days for $1,448 worth of material. Now, oh, by the way, it took us 8 weeks to get this guy in. And the company that made it was Rapid Machining. They did a great job. But how many times have you all worked on electronic systems, right? And you're trying to figure out your cables and your connectors and all that crazy stuff. You might even have an EMI problem inside the system. And you don't find out any of this until you wait for 8 weeks and the $8,000 box shows up and it's wrong. When you go do 3D printing, right, you can take this box and get it done in 3 days. 3 days later, you know everything that you gotta go change for the next version of the box. And it hasn't cost you $8,000. So, we had a material inventory. And I'm about done with this section here, but what I'm gonna do here is I would like to encourage you to take one of these sheets with you when you leave tonight, okay? Now, I haven't got it set up yet on Dropbox. But all of the files and PDFs and movies, you know, MP3s and whatnot that are on here, I'm gonna put them out there on Dropbox. If you give me your email address, I can give you the instructions on how to get in there. But this is what we gave the highest ranking guys in SoCon that came out for tours. And they don't know about 3D printing, so I said, okay, take a look at this. I went out and I found 3D printing stuff for military applications, for metal applications, for really large parts, okay? For circuit boards. Did I say circuit boards? Did I say RF waveguide? 3D printed? Oh, yeah, oh, yeah. And so all this stuff, and then actually, these are all movies, like little videos you can watch, okay? So if you wanna be able to look at that, because you might have an application for it, just get the sheet, let me have your email address, and I'll send you the Dropbox stuff. So, all right, so this is just a 3D printer. We had a maintenance schedule, best practices, things like that. It was very finicky, like a Lamborghini. And so, any questions?
So you have to
Okay.
take, okay, you have to take two's a good one. That's excellent. Thank you so much, I appreciate it, I don't have to take.
I'm not sure.
Well, think about it.
I thought about it. It's 250 megabytes.
I have a hard drive that's pretty big.
But I could put it out to Dropbox. Would you like to get that?
Yeah.
Okay, just get a card, send me an email, all right?
You mentioned that you could use conductive ink, so as the printer was coming in on a circuit card, or even on the, whatever it was gonna be, you could
Yes.
embed the conductors for communications or electrical inside the structure itself without having wiring.
Dave is correct. I think with your permission, I might just skip some of the stuff I was gonna show you.
I think I know what he's interested in.
Okay, well, because you guys are the leaders, avionics, electronics, okay? I can show you some stuff that just amaze you, okay?
You make a question?
Yes, sir.
So you're saying, what you're saying is you can make a PC board with how many layers? How many you want?
30, 32?
Oh, that's pretty good.
Oh, it's, okay, I tell you what
And
we're
that's
gonna do.
just a start.
No, this is what we're gonna do.
What's the diameter of the actual ink that you could get? Could you do like a number 16 or a 24 gauge ink blot that would be a series of blots that would then turn into a conductor?
It's just like an inkjet printer. Okay, it's just like that. Think about an inkjet printer, it's got a color inkjet printer, right? Not black and white color. And I guess you've got what, I don't know, you probably have on the print head, you've got 4 or 5 primary colors, right? Whatever the hell they are, yellow, green, okay, all this. Okay? And the software in the printer is taking a look at your PowerPoint file.
We'll start in the upper left-hand corner, and we'll work our way down.
Okay, here we go, ready? This is, okay, now. We're gonna have to leave it like that. I think that'll work. It does, okay. Now, I don't sell 3D printing equipment. I don't even wanna go to work for somebody who does. I just like the technology, so whatever I tell you tonight, there's no quid pro quo. I'm just telling you what I have found, okay? So. Are you guys on LinkedIn, right?
Yes.
Okay, you need to get a professional, the membership, the premium membership, whatever the heck it is, okay? Well, hang on, because they have these learning modules. What you will see in the slide deck, okay, you might not see all of them tonight, but there's, and I honestly discovered this 5 days ago. When I'm putting this whole thing together in my head, and I go out to LinkedIn, and there's this one thing about 3D printing, and I looked at it and watched all the different, it's about an hour and a half. It's fantastic. And there's a link to it right down there, okay? And in fact, it's called Additive Manufacturing for Business. It's great, okay? Because I'm not selling 3D printers, I'm trying to share information. Here we go. All right. Come on. History of 3D printing goes back a long time. It's about 30 years old, okay? Somebody tell me what time it is?
6:47.
Wow, okay. Wow, okay. Okay, so what you start off with is you start off with a CAD file. And when you're in SolidWorks or Pro E, whatever it will do, you say, I want to save the file in a certain format. That format is called STL. It stands for Standard Tessellation Language. And I didn't know that until about 2 days ago. We just called it STL files. You guys got Gerber files, right? What does Gerber stand for? And so you take your CAD file, you save it as an STL. Oh, that's a battery case. That's a circuit card modeled up in SolidWorks with all the right components and all the mounting holes and all that happy stuff, right? You got a mechanical engineer working on your program. You got a board that's got to fit just right. It's got connectors on it, Lord knows what else. You can take that 3D CAD file, save it as an STL, and you can print that thing up. Do a fit check on your program before you go to Epic and build 5 or 20 boards, right? It's a wonderful thing. You're not limited to just brackets and stuff. This sheet metal here, let's say you were gonna go build 250 of these guys, right? Because you got a production run, you're an LRIP, low rate initial production for a program. Or maybe you're just going to a design review, maybe you're going to PDR, maybe you're going to CDR. And you want to show the customer how you're going to mount all your electronics and mount your cables in this thing, but you don't have a lot of time. And you know it's going to change anyway, because you go to PDR, they change something, right? Just for the hell of it. Print it up. Print it up. Because you're not going to be taking this thing and dropping it out of an airplane. All you're doing is sitting up here, mounting your connectors, doing your fit check for your cables, and you get it like in a day.
Doug, was that metal? I'm sorry. Is that
sheet metal, aluminum.
Wow. I'm sorry, is that printed?
No.
Okay, it's just, okay.
No, but you could though, just like.
I got you, okay.
This guy right here. So, you start off with a CAD file, and actually I'm looking for like one slide, okay? It'll be here in just a moment. Ah! That's not the slide. There. So this young lady here, right, your CAD file that you have, you can design it in SolidWorks. You can just design it, just like you would just sheet metal printing, right? With all your cutouts and stuff like that. But what so many people are doing in other businesses is they're saying, okay, I don't know who this guy is right here, this statue. But let's say that this is the only one in the air, on the planet. And you want to make sure it doesn't get lost in case the building burns down. They're 3D scanning this stuff now. See this screen up here? She's just illustrating the scanner and the software that takes all of that input there and turns it into that, and it's preserved. And if you want to take that statue right there and make one this big, you can. If you want to make it as tall as the room, you find yourself a 3D printer that will do it, it'll do it, all right? They even use scanners on really large structures. Now this is something that's pretty small, right? That's not the one I'm going to show you. That aircraft, airframes, reverse engineered the right front fender on a Jaguar XE, you scan it. Now, you might get in trouble with Jaguar, but you got the perfect geometry, like you was a motorcycle helmet, anything like that. There's so much reverse engineering going on right now, it's amazing, all right?
So Doug, just real quickly, I mean, based on what you just said, it seems like if I went out to Home Depot and I found, like, I don't know, like a knob or something like that, wow, this is great, I need 40 of these for my house. If I bought one and I had, of course, the appropriate material and printer and stuff, I could scan it potentially and then just, print until the cows come home. Is that a correct understanding?
Or you could take it to Beijing.
All right, there we go, okay.
Shanghai, and have them print 1,000 of them.
There we go.
Cents each.
I have a question here.
Yes,
With respect to the software, the process, the software that is needed to go from instruction set to the actual piece that is being printed, what is the type of software that is used there?
I have no idea.
Okay? Because I know that if you're using, for instance, in numerical control machines, you have a software that is the GPIO, you send it out there and it converts it into another type of software that sends the signals on how to move the machine.
Yes.
But now you need to be able to convert it to warehouse solid stuff that you're producing.
The best example I can give is just like a programming language, like I used to do Fortran, right? And there's this thing called C now, C++ that people use, right? I don't know how to do C++. But at the end of the day, C++ or Fortran or BASIC or any of these other languages, Java, doesn't matter what they are. The computer takes all that, right? And at the end of the day, it takes it all down to hexadecimal code, doesn't it? At the end of the day, to make something turn on, turn off. It's all hex. And that's what happens in a SolidWorks file or a Pro-E file, CAD file, where a scanned 3D image. It goes through all this mathematical magic. It's like, hey, now I'm an STL file. So,
I would imagine that each manufacturer of a 3D printer has its own software that'll convert a SolidWorks file into theirs.
no, sir. One of the nice things that's happened for CAD systems, there's about, well, there's CATIA, there's Pro-E, there's SolidWorks, there's some other stuff. The graphics is still hanging on it.
Fusion 360,
Sir?
there's Fusion 360.
Yes, sir. So there's about, I don't know, maybe 7 different major players in the 3D CAD market for military stuff. And fortunately, one of the things that happened was about 20 years ago, they all realized that sometimes, even though they're competitors, they gotta be able to share files back and forth. So, so they came up with what they call the STL file. It's like the Rosetta Stone file, okay? And so, but what happens though, like for example, within SolidWorks, if I wanna import a Pro-E file, my SolidWorks software has its own unique algorithm for taking all that 3D geometry and everything else from Pro Engineer and turning it into SolidWorks. Of course, Pro Engineer has one too, and CATIA can read Pro Engineer. You've got to import it, but all those importation software packages, they're all unique to SolidWorks, Pro-E, and CATIA.
I guess I'm still a little puzzled. I understand what you're saying, but what I'm puzzled about is, at some point, an engineer who's used to a particular design program, let's say, continue to talk about SolidWorks.
Yes.
He wants to take his design and turn out something that will talk to the printer and make the printer work.
Yes.
Now, I think what you just said is that actually SolidWorks has that capability built in.
Yes.
And so it knows all these different printers, and you can tell which printer it's gonna go for. Maybe they all read the same language.
They all do.
Okay.
That's just it.
That's what I was missing.
All 3D printers. I mean, to my knowledge, STL is the only file type that a 3D printer will read.
There you go.
It's it. It's like, I I mean, I can't think of the electronic equivalent, but it's the only one that's out there. So if you're SolidWorks or Pro E or CATIA, you have to get it down and to translate your file into the standard STL format, and then you can send it to any 3D printer.
Like, at the end of the day, it's gonna go to ASCII text.
There you go.
Yeah.
ASCII rules.
That's it.
No matter what font you used, right? Hey, we have a question back here, Doug.
Oh, I'm sorry, sir.
Pro E to SolidWorks is also the STL file.
I'm sorry.
When you go from Pro E, it's also the STL file that they exchange back and forth.
No, it's not. I mean, what happens is, if it's SolidWorks and it's trying to read a Pro E file, the SolidWorks company had to hire programmers, right? And they had to look at all the things and make up the geometry, and it's all math. It's all like, God knows what, crazy math, right? And they took this Pro E part, and they can read the surfaces and the edges and the radiuses and everything else and bring it into SolidWorks. But Pro E didn't give that to SolidWorks. In fact, actually, Pro E hates when SolidWorks does it. And SolidWorks hates when CATIA can import SolidWorks files. I mean, they're very competitive. It's like Coke and Pepsi, right? And,
But both of them use STL to drive the printer.
yes, but everybody has to use STL to drive the printer, so.
So that that's actually pretty interesting. It sounds like what they probably do is they reduce all the really cool stuff down, as you said, to ASCII when they peruse the STL file, and then they drive the printer from it. But if you want to do all the really cool stuff, you keep it in your proprietary language that says how to do things, and that's why you need to have custom translators between the different applications.
Well, the STL is actually an abbreviation of the word stereo tone record.
Yes,
Wow.
Yes,
All right.
it is.
There we go.
so.
So it's an easier way to remember. What is the word?
I'm not sure if that's actually easier. Just
Stereo tone record.
It's actually the first process that we were gonna look at tonight, but I won't. I'll send you the presentation.
All right.
Okay, so,
It's my card.
this is, there's like, I don't know, 8 sections to this presentation. And I knew I wasn't gonna do all of them, I knew that. So, this is metal stuff. Okay? Oh, well, you've seen some of these slides. But some of this stuff you haven't seen. And I gotta tell you, it's just the best stuff. It's just incredible. As Jackie Gleason would say, and away we go. All right, so, I know you all are electrical engineers, 17.4 pH, 6061 aluminum, all these different alloys, bronze, brass, Linnell, Hastelloy. If you need to have this valve body here for a corrosive environment and you want to 3D print it, you say, I need Hastelloy C, it prints it. And there's a lady, she's in Italy, I can't remember her name right now, she's on LinkedIn. Her company is 3D printing metal, hydraulic, and pneumatic manifolds, heat exchangers, heat sinks and stuff. And let me tell you what happens. Remember we had the example a couple minutes ago, you have a 32-layer board and you want to embed an antenna inside of it, right? Just for grins. And it's got that helical Christmas tree shape going up like this. Well, you can do that with metal. You can do that with rocket engines. If you've got some kind of pharmaceutical process, and for some crazy thermodynamic reason, you need to take your fluid through here, right, and make it go around and get turbulent, whatever the hell it does, okay? Go through a corkscrew and then make, like it's no different than an anthill. You know, you've seen slices of anthills, all the different places they had downstairs there. You can 3D print that. You can, and it's completely unmachinable.
You could put the threads into the
Well, threads are different, but you could print threads if the resolution on the machine was high enough. Right? These threads are kind of funny, they gotta be strong, right? But, so here we go, ready? That's a jet engine that's 3D printed. You know about jet engines? I'm not an expert, but they get hot, they
Yeah.
get hot.
So the metals after 3D printing behave pretty close to the way metals have behaved in machine room.
80%. That's just my guess off the top of my head. 80% or better.
Close enough for the purpose.
Sir?
Close enough to what they need for the purpose, because that's gonna get hot.
Absolutely. And you know, you have thermal expansion and all this other stuff going on, so if you have micro porosity in your part's not gonna expand the same way, and you know, all these different factors. But, okay, here you go, now look at this. That's a SpaceX rocket engine. And what they're not printing the whole thing. See all this down here? Nozzles? That's what they're printing. You'll see in a minute. It's just incredible. There you go. Look at
Print
this.
ceramics?
Ceramic, this is actually aluminum. Yes, sir.
You're talking here about, SOCOM, therefore you're talking about, military. So how do you go about imposing a mil spec into a printing job? Is that part of the software that is being already
No.
inserted in there?
That's actually a really good question. In the mil spec, you know how they have mil specs for capacitors and resistors and dip switches and things like that? You know, a mil spec, blah, blah, blah. 38999 for, you know, series 3 connectors, right? It's gotta go do this and this and this and this and this. There's a mil spec for materials. I think it's 510. It's something like that. It's something like that. And it's got every metal ever worked with by mankind. All right, back to the Babylonians. And it's got the tensile string. It's got everything in there. Everything that's ever been used. They're gonna have to expand it to incorporate 3D printed titanium. And what that also means though, they'll probably, I would bet they're gonna end up with 3 different grades of that. They're gonna say 3D printed titanium that's made this way, and this way,
Oh, wow.
right? Because it's like a chocolate, it's like icing on a chocolate cake, which is dear to my heart. My beautiful wife, Catherine, got me on a keto diet.
Oh, sorry.
And there ain't no more chocolate cake within 100 miles of my house. And there's no ice cream either. But that's what's gonna have to happen. They'll have to, because see, the problem, well, not the problem with mil specs, but the reason you have mil specs is whether it's a resistor or a connector or a screw. When you got it on a B-1 bomber or on a JDAM missile or whatever the hell it is, right? You gotta make sure it works.
The same characteristics.
Yeah. So there's a rocket engine, this same rocket engine. And just to show how clever they are, this same rocket engine, they just printed it in halves. And see all those little supports and stuff and all those little channels and stuff inside there? You couldn't cast that, you could never machine it. It's just incredible. So anyway, we're gonna get done with rocket engines. I think this means we're gonna talk about circuit cards.
Hey, Doug, super fast questions, especially with rocket engines and stuff like that. You know, so it was a long time ago that I owned an inkjet printer, and I seem to recall every once in a while the heads would get clogged.
Yes.
Is that a problem with 3D printing?
Absolutely.
Okay, all right.
I don't know, you might not remember. It was about 12 minutes ago, I showed you, we went past the slide really quickly. It was called best practices, the 3D printer I had,
Uh-huh.
okay, I was responsible for it. And the reason I put this together was because I was always afraid some colonel from SOCOM would come through and say, you know, I was on the tour 3 months ago and you could go do this and this and this and this. Well, I tell you what, I need 3 of those big drones this weekend, because I mean, our guys are going to Somalia or somewhere, and we gotta have those drones. And I'm supposed to say, well, I can't, Colonel, because my machine's broke.
Oh, no.
So I kept this thing, I'm not a mechanic, right, but I kept this thing running like a Maserati. And I had a cleaning procedure, I cleaned all the heads and everything in the machine before I did a print job, after I did a print job. I had a maintenance schedule for weekly stuff, monthly stuff, annual stuff. Because I had to be ready when the job showed up. We're gonna talk about circuit cards here now. I don't represent anybody. there's absolutely no quid pro quo between me and any other printing company out there at all. I just know about it. When I was at SOCOM, I found out about electrical printing circuit cards, okay? And this company, in fact, I can't even remember who these guys are, okay? Looks like a pretty good board, though, okay, I'm impressed, it's a big board, okay? It's probably a panelization thing, who knows, right? It all looks good. This young lady works for Nano Dimension. They're out of Israel. They were just bought by AESS. You know, the guys on the East Coast, they go through the layoffs all the time. So, Nano Dimension sent me samples of their circuit cards, 3D printed circuit cards. There they are. Well, that's their pictures, okay? Somewhere in this presentation, I can show you what the real ones look like, but it's probably slide number 157 or something. We're not gonna go there. But this is the real deal. This is the real deal. This is the real deal. Let's go back to a moment for a moment, what Dave had mentioned about inductive inks and things like that. Because that's what you have to have. When you're printing your vias and stuff, right? And your holes, plated through holes for your through hole components and things like that. You're using conductive material, and it's gotta be solderable, doesn't it? It has to survive soldering, all the temperatures and all that stuff that's going on. It ain't, you know, surface mount components, you know?
So you can actually make a
SMAs.
fillet, you can make a
Sir?
fillet of
SMAs.
Absolutely, everything. So I mean, so this is not just, these are not pretty pictures here, okay?
So that-
This is the real thing.
We call it a fillet, the hole where you're gonna put the component through.
Yes.
So you can make in the print board, and then that little section of the fillet will be almost a metal that you can
Yes.
solder.
It's a conductive material. And obviously, it's probably, the gentleman asked me a moment ago, a while back, how do they make these resins and stuff? Well, it's like trying to get the launch codes from Russia, okay?
Talk to the chemistry guy.
Yeah, that's what makes them special.
There was a period, and it's gotta be 35, 40 years ago, where circuit boards were, they call them printed circuit boards because they actually used a printing process, silk screen printing
Yes.
process.
Yes.
So it's
Graphic,
ink,
yes.
Yes.
Print it on there, and then you bake it, that would bake off the
Yes.
the polymer or whatever, and you have metal.
Yeah,
And it's very much like this is the more modern version of that.
it is. And by the way, every time, okay, so like when you got a plastic card, there's something we just went past it. Okay.
Probably pass it around.
Well, what I wanted to say was, let's pretend this guy's upside down, you gotta print it. Every pass is about 5/1000 of an inch thick. Not very much. 5 to 10 thousandths of an inch. So when you get a part like this or a part like this, it's gonna be, you know, a lot of layers. This is a photo resin. The machine I had, the Connex 500 that I did all this stuff with and other things, okay? It's a photo resin, a photo curable resin, right? And so what the machine does is it comes by with the inkjets, right? The print head, puts all the material where it's supposed to go, and then a UV light passes over it,
Cures.
it cures it. And then it goes back, and then the print head comes back again, puts the next 5/1000 of an inch down. Exactly where it's supposed to go. It's really amazing.
So how long is one pass plus cure time? What's it, what I'm thinking is, all right, it's
30 seconds. Well,
It
it depends on how big the part is.
Well, yeah, it depends on the printer, right? Because there's other printers out there where you have to put it in a cure box.
That's metal printing. See, that's completely different from this stuff. But in metal printing, as my understanding of it, okay, is that they take if you printed this box here, this enclosure, out of metal, what it's gonna do is it's got a binder inside the powder that gets deposited. right? Everywhere it's supposed to go.
You're gonna cook it.
You cook it, you put it in the cure box, it goes into an oven, depending on the material and everything else they know how to go do with that particular type of printer, that process. You leave it in there for maybe an hour, maybe a day, I don't know. And it lines everything up, and it comes out. So that's metal 3D printing.
And there is really we're gathering two different times when you cure it. Because you have to cure every sheet, every layer, at least somewhat, otherwise you can't do anything more.
Yes.
But then when you're done, you gotta put through this baking process to finish the job.
Well, in the metal box process that this gentleman was talking about, there is no layer by layer cure. It goes in the oven. It goes in the cure box looking just like this. And the same thing for this guy. He would go in there looking just like this. Now, obviously, it's metal powder glued together with binders and stuff, so
Yeah, the metal.
you gotta pick it up really
It
carefully.
very
It's gonna
carefully.
be soft before it
Well,
bakes.
yeah, you're not gonna just drop it in there.
Like, like putting clay before you go into the kiln.
Yeah, right. So,
Okay.
anyway, circuit cards.
Well, in that case, just like with clay, when you're baking it, if you haven't done it all exactly right, then it can break itself apart in the baking process, because the stresses aren't properly handled.
Yeah, or we get air bubble in it.
Yeah. Okay, I'm getting it.
So you could actually simulate this or make it similar to a reverse CAT scan. Would it not?
Yes. Well, a CAT scan is very much like, when the young lady was doing the statue, okay? Or somebody's standing over here and they're doing a Maserati, or the hood of a Maserati, or a Maserati fender, whatever. It's just like a CAT scan.
Yes.
In fact, somebody, I'm sure out there, some software, right, has figured out how to take the data from a CAT scan, because it's just geometry, right?
Mhm.
It's just geometry, in an electronic data format, and they've taken it and they know how to go do all the things to it and make it an STL file. I know I'd be doing that. I mean, I don't know, I'm not a software guy.
GE
Apropos,
builds.
I just read
I'm
recently.
sure GE builds have their both proprietary.
Well, I just read recently that in fact physicians and surgeons are using CAT scans to create a file, and then making an image, a physical image this way, so that they can look at the thing they're gonna see when they finally cut into you.
Yeah.
They're making hearts.
Yes,
Physical
yes.
heart, the same size as a
And-
heart.
And when it comes to 3D printing medical parts, are any of you guys in the medical business? I know Dave is. Medical business, anybody? If you think that NASA has tough requirements when they put a Mars rover on Mars, about all the things you gotta go do,
Medicals.
they're pikers. They're pikers, they're amateurs. I worked for Convent on a contract for 3 months. It's just crazy. The validation, they call it good manufacturing practice. You gotta keep track of everything you do. It's just crazy. But people are doing 3D printing for metal pieces and for plastic pieces for surgical implants. Because the technology and the materials and all that stuff, right, just got them there. So, nano dimension. Now, I gotta tell you, again, I don't have any stock in these companies. I've never actually met anybody face to face, okay? But Nano Dimension did send us about 5 beautiful samples of 3D printed circuit boards that I got to show SoCon. If you're thinking about doing this, if I was, you know what I mean? Call these guys, because to my experience, the other companies, and there's a couple other, only like 2 other ones out there, you'll ask for samples, you'll ask for information, you may never hear back from them again, but these guys you will. So, this is one of their big machines, and I'm just showing them to you for reference. Okay, take a look at this, look at these guys. They took, what was this thing called? It was a bottle cap or something. It was a battery holder, there you go, battery, okay? What did they do with it? When they 3D printed this thing, they embedded an antenna inside of it.
Wow.
That's the future. if you're doing stuff for SOCOM or those other folks, and you're trying to do clandestine stuff, or else you just wanna make a better coffee cup, right? Not everything is gonna be like this.
Coffee cup with a heater.
Yes, it is. So,
The heating element.
so, there you go. Okay,
There it is.
okay. Now, I found this afternoon, I'd never seen this before, but apparently nano dimension, and they really are the guys right now. Now, 2 years from now, they may not be. It's like beta, and what was the other thing they had way back when? Beta, Sony, you know.
VHS?
VHS, yes, thank you. With SolidWorks, and you get a copy of the presentation, you probably just have to go Google on YouTube, SolidWorks and nano dimension. Here's a case study. I didn't even watch it. I was finishing something today. But when SolidWorks teams up with their name with somebody like this, it's all good. Because SolidWorks doesn't mess around with just anybody. There you go. Now we're gonna talk about, oh, now this is another company, okay? It's called Voxel 8, and it does circuit boards, okay? And that's all I know about it. So there's other people doing it. Waveguide. That was something the ESA, European Space Agency did, okay? Just a piece of it. Waveguide pieces, sections. Da-da-da-da. Let's go back to this last slide here. I'm not an RF guy, but what I do know, see that cross section, that rectangular section right there? It's really important. RF guys here? Okay. That's really important because it controls the way the signal's propagated to the part, I think, right? Something like that.
The frequency.
Yeah, the frequency thing. And so, the geometry is really important. I don't know what they were doing here, okay?
That's how you tune it.
Oh, see, here we
Right.
go. Look at that.
You tune it with, little screws, just put screws in there.
Just like a trumpet.
And also.
So I had somebody try to explain that to me about a year and a
This
half
can
ago.
also be horizontal or vertical. You could go from horizontal to vertical polarization. That would be like all
That's right.
horizontal.
Yeah, we did that, we did a lot of that with SATCOM,
Exactly.
switching. So, as you can see here, now, I would hazard a guess that this part right here, it probably required what they call post-machining. They probably, now, unless these things are threaded, in fact, these guys are not threaded. If they're gonna put a screw in there or a thread piece, it's not threaded. You don't 3D print threads. It's just, unless it's like, I don't know, for the, smokestack on a battleship, okay, you're screwing it in, but otherwise, you can't. But they probably require somebody to go in there and thread those ports. Maybe, depending on how the part came out, on the 3D printer they're using, and the process they had, they maybe had to do some cleanup inside here, okay? So it's not like it popped out of the oven like a, like toaster strudel.
Also, a lot of times this is gold plated on the inside for
Yes.
extra conductivity.
Exactly. So
Less
there's
resistance.
things they have to go do to it later on. But in terms of getting a part, I mean, if you made this out of a casting, the tooling, holy mackerel. When they get done, everything else, to go make this part and all the inserts and everything else, hell, it costs you a fortune. It's just, and then you make one, you make two, oh, it's not right. So you 3D print it.
This unit was pretty rough on the outside, so that means that it was actually rough.
Probably so, probably so. I mean, waveguide's tricky. More waveguide. I found this, okay, apparently some guy, okay, let me show you this. You see those 3D printed waveguide parts right there? All right, well, that was the first picture that I got. The second picture was this screenshot, is Mr. Chan, I believe, and Rodrigo Romo and Roberto Sorrentino. They actually took that waveguide and tested it to see how it responded. And I'm not a science guy, but, you know, there's things that it has to do. And they wrote a paper. So what's happening is people are 3D printing waveguides and actually using it in real applications. 3D printed waveguide section. Okay, see, here's the article. Okay, 3D printed plastic waveguides enable V-band applications.
Doug, you got about another 10 minutes, sir.
We're done.
Oh my goodness. So it's question and answer time?
Yes.
I actually have a question. I'm under the impression that there's certain things that today, with regular like milling equipment, we can't make that you can make with 3D printers. Do you know the sort of like why you can do it with a 3D printer if you can't do it with like a traditional milling machine? I think I read something about like car engine parts or something like that. It's like you start with a block of metal and there's things you can do with it, but if you're building it from the ground up, you can do things that you can't do today. Or
If for some reason inside of a reader engine, or a heat exchanger, or even a heat sink on board, that goes, it's in a really demanding application like a spacecraft, right? I mean, it's gotta work, and you only have so much weight, you got a weight budget, you got a size budget, and it's still gonna dump all this heat. It might be that what you end up designing from a mechanical standpoint to meet all the, and you have to have, to meet all the thermal transfer characteristics, right? And, you know, the surface area, and all these different things that are wrapped inside this heat sink. It might be that you end up with a geometry that if you went to go machine this thing on a 3-axis CNC, it would take forever. But if you want like if you really wanted like a pigtail, right? Of course you could do this with wire, right? But let's say you wanted a stainless steel pigtail on your heat exchanger or your heat sink, for whatever reason, you print it.
Think about Venturi,
Yes.
where you're gonna have a pipe with a
Yes.
mixed geometry to create the
And-
low pressure side.
Yes.
On a Venturi, that's gonna be elaborate machining, but
Yes.
you can print that.
What's gonna
Slopes.
happen? Yes. What's gonna happen when they go to Mars, and they're already working on this? So you're on a Mars mission, and I don't mean the first one. The first one, coin toss, right? Too much radiation. But, if you're sending 6 guys to Mars, 6 people to Mars, and it's a 2-year trip, you're gonna wanna have a 3D printer on board. Because if a light switch breaks, or something breaks, or whatever it is, you can't carry spare doorknobs. You know, you're talking about, yeah, like that.
They could have used a 3D printer on Apollo 13.
Yeah.
Really good over there.
Yeah.
Gaskets.
Gaskets, I tell you what, I spent so much, I had a couple display tables at SOCOM, full of just rubber parts, gaskets and stuff. Let me show, I'm not gonna take the picture because I can't get there. I mean, it's there, but I took a drone, downloaded it from a site called GrabCAD, right? They've got all kinds of stuff. They have like the Mona Lisa as an STL file that you can download. They got, now, see like that lion right there? That's where they came from. Some person modeled that up, put it on a GrabCAD, and if you go look for lion, you get that, along with 50 other ones. So this drone here was downloaded from GrabCAD, and I made some changes to it. Not a big deal. It was this one drone. Different geometry. I printed it out, Barbara, just to show them I could. right? They would say, what are you gonna do with a rubber drone? Nothing.
What site is
So,
saying?
yes, sir.
You can
Do
download
the
it.
different resins and
Grab
chemicals
card?
have different fumes or outgassing while you're printing them? And if they do, could you put it in like a cubicle environment where there's other people working in the office and whatnot, or does it need its own separate lab with a fume hood or something like that?
Well, I'm gonna do this from memory. I think the answer is yes, and then no, and no, and no. It's like a really quiet dishwasher. You know, the old dishwashers help you go to sleep at night, and the new ones, you can't even hardly hear them, but you can. A 3D printer like the one I had, right? When it's running, you can hear it. In fact, it sounds like a copy machine. You know, a copy machine can print out 5,000 pages. You know, and you're like, well, let's say it's way over there, and you're way over here, and or maybe it's the next cube or around it. You can hear it. You can hear it. There is outgassing and fumes and stuff. Okay, you can smell it. I had to do an air purge on my lab about every once a month, right? Open all the doors and get fans and stuff. It wasn't that it was toxic. It just didn't smell good. And that was for plastic. The metal printers, because they have all those binders in there that bind all the powders together and stuff, there's no telling what's going on. So I said this earlier, you do not want, okay, guys you're working with on your teams, they go, gotta buy a 3D printer. Now you can go out, buy one for $1,000 and you can make coffee cups, okay? And have fun. Do not do a capital expenditure right now for a 3D printer. Don't do it. Number one, the technology is changing so fast right now, okay? And what you buy today, you'll be able to buy in 2 years for 2/3 or half the price. That's the first consideration. The second consideration is, I'm not a mechanic, but if one of you, and after having said that, if one of you guys had a Maserati, would you let me work on it? I don't think so. And these things require serious maintenance by people who know what the hell they're doing.
Do you do a lease option?
Sir?
Lease rentals?
No, you actually don't want the equipment on site. You don't even want to lease it, because what's gonna happen is you're gonna have to learn how to run this thing. You know, like, Hunt for Red October, right? They got Jonesy down there in the sonar room, right? It took Jonesy a long time to figure that out and get the touch and learn the art of it, right? Of listening for submarines. So, yes, sir.
Getting back to this Holmes' question for a minute, it didn't occur to me until he did ask the question, but I'm guessing that if we went to the NIST website, we'd probably find specifications for things like, looking at the consumer grade printers that you see in homes or schools. Obviously they're designed to minimize or eliminate outgassing so that people are protected. But I'm guessing with larger industrial grade printers that use metals and other substances that could give off toxic gases, there must be specifications for venting that in order to prevent people from being injured by it.
Yes. Those rubber things I passed around, those panels, they're about a year old now, year and a half. They smell pretty bad for about the first 6 months. I mean, it wasn't real bad, but you could put it right here, you wouldn't want to eat your dinner. So here's the other thing I want to talk about. They have these guys called circle. Go ahead. Yes, sir.
Yeah, my question is that you just mentioned a little while ago about the technology is moving fast and what you
Yes.
spend today may be worthless tomorrow. So what's your recommendation there? Like, is the cost going down or the technology improving? What's
The
the?
technology's improving. It's just like Moore's Law.
Yeah.
Okay. The technology's improving.
Yeah.
The software's getting better. Do more.
Yeah.
Better surface finishes inside waveguide, things
Yeah.
like that. If you have to get some 3D parts printed, the good news is Stratasys, Object, all the big companies out there that make these 3D printers. Protomold, really great company, okay? I've got a book here somewhere, I think. Protomold. They have service bureaus. Call them up. And the best thing about those guys is, you don't have to go buy a machine and do 6 months of the learning curve to find out the difference between 3D printing aluminum and stainless, because they've already done that. And you send them your CAD file and they go, what's your scale factor? I want it to be exactly this size or 125%. How many do you want? Blah, 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 blah. You send them your CAD file and you get them back in a nice box. And you gotta pay for it. See, you were gonna go pay for it anyway if you bought the machine. And you get a good part. You get a good part. Cause I gotta tell you, a lot of parts I made, downloaded from the internet and this and that, man, it's tricky. It really, I mean, if your walls are too thin, or you're doing, you know, plastic snap fits and stuff like that, you gotta be right on the money. You go to a service bureau.
You know, that might be the most valuable thing you learned tonight, right?
Or even a good pizza.
I love new toys. I'll go out and buy a new toy in a heartbeat, but you know, that guidance actually makes a great deal of sense, right? Have somebody else who has like 20 of these printers sitting around their office and they can keep it up to date. They get the new software.
Well, and the other thing that happens is if you guys actually have $500,000 laying around that you wanna do this with, you still wanna do the service bureau for about, I don't know, 6 months or a year. Say, now, what kind of machine did you make my coffee cup on? We used an Acme, blah, blah, blah. Then you go visit Acme and find out the machine's only $235,000.
I'd like to make an analogy here, very quick. This 3D printer, printing setup that we are discussing today, it appears to me that it's the precursor, if you will, of the Star Trek replicator that we have seen.
Absolutely.
It always goes back to Star Trek, doesn't it?
Yeah.
The guys over at
But that's mechanical, analog. It's the analog equivalent to Star Trek replicator.
There's a big difference between creating something that's, consists of matter out of energy as opposed to taking one form of matter and converting it to another form of matter.
So Doug, you've done a great job of explaining to us.
Analogous but different.
We can print in plastic, we can print in rubber, we can print in metal and stuff like that. Is there anything we can't print in today? I mean, I can't think of anything, but is there any substance that you know of?
You take any metal, you could take uranium, you could take plutonium. If you were to make a plutonium statue, that lion right there, and still have it be radioactive, maybe you're gonna give it to somebody, right? Right? You can do it. All you gotta do, right, is just get it powderized and put it in the resin and everything else, and turn the printer on, and you know, drive to Orlando, right? Well, it makes your part.
Gases, 'cause they would move.
Sir?
You know, a gas, you can't print a gas.
Can't print a gas, that's
I
right.
agree.
You know, an interesting point, and actually, we just had mentioned over here, you know, they are printing human body parts, you know,
Yeah.
right? I mean, so I guess.
Tissue.
With
Bones.
You know, bones and cells and like printing a heart and stuff, I mean, we're not there yet, but
Skin.
it's coming, right?
No, it really is, and by the way, you go look up 3D printing for medical stuff on YouTube, Google, whatever. It's not a niche market. It's as big as this room. Everybody's doing it, and it's crazy, it really is. It's really neat.
Excellent. Do we have any more questions for Doug?
Yeah, one last one comment I want
Yes.
to make. Do you think that one of the college I was working, they just spent $40,000 to buy a huge, big size printer?
Yes.
When they had already a bunch for the students. Do you think they made a mistake by buying this thing?
Well-
Because it's 40,000 investment, and I don't know, it'll become useless, as you said, in a few more years.
It's never gonna be useless, okay, but it's like, you know what it's like? It's like, when we were all younger, we all ran out and bought an Apple. And then one time, we all went out and bought a 286 computer, because that was just, and then it had a math code processor. I mean, it was like,
Yes,
oh,
yes,
right, this is
yes.
good, right? And then what the hell, they came up with a 486, the 586, then the Pentium, and that's what they're doing with 3D printing. Now, I do think, I don't have a whiteboard here, okay? But I do think that in about 3 to 5 years, they're gonna start to peak out in terms of the resolution they have, the speed they have, the materials they can have, because they can handle, because at the end of the day, it's no different than a what? Not a lawnmower, but it's no different than a car engine. You're still gonna have to use some kind of gasoline. You're still gonna have valves and lifters and all that other stuff that's going on, right? It's just a question of how better you can machine the parts, et cetera, et cetera, et cetera. So it's gonna be, the technology's gonna really mature in the next 2 or 3 years. And that's actually when you wanna buy a 3D printer. Because everybody will be doing the same resolution, have the same computing power. It's just like cell phones nowadays, they're all basically the same.
Well, I think, the limiting factor would be the resolution or the diameter of the jets.
Yes.
And how small can you get it? Once you're down to a molecule,
Well,
I mean,
fair enough to
how
say.
small can you get a molecule?
And so what happens is you get into fluid dynamic problems, you're trying to put residue nozzles, you know, and all the pumps and all, I mean, you take these liquid resin printers, there's a lot of stuff going on inside that thing. You got pumps, you got, everything's gotta be the right pressure, your UV curing lights have to be the right intensity, you know, band, tolerance band, all this stuff.
The temperature has to be
Oh,
exactly right.
the temperature has to be like within about 3 degrees, and if it's not, the machine just goes, I'm done. So it's a hell of a machine, it's very complicated, and so, there you go.
Excellent. Doug? Now here, when AESS puts on a presentation, what we like to do, we could give them like a silly little award, a little plaque. But instead, what we like to do is we like to give our presenters chocolate. And so Doug said,
Dave.
Now, you know, he said he was on the keto system, which is fine.
No.
There's no problem. So I give this to you.
No, this is great. Is that a picture camera? Oh, can you take a picture of this? Because I can show my wife, Catherine. I didn't buy this.
No, that's, you did not. No. Well, there's actually a couple of other interesting points here. First off, we're giving it to you tonight, but we're not going to tell Catherine now, are we? And you've got to drive home. So stay with me on this one. You see where we're going?
How to get on Twitter?
What she doesn't know wouldn't hurt her. And even if you don't eat it, the good thing, Doug, is that you know people who like chocolate.
Yes.
So suddenly you have a powerful bargaining tool, okay?
Well, I can tell you, I am gonna eat this.
Yes,
I'm
yes.
gonna have breakfast.
The horns are on. Excellent. Well, this was a heck of a presentation, right, guys? One more round of applause for Doug. Thank you so much. I know I learned a lot about what I don't know. So thank you very much for sharing.
Okay, so, other thing was, if you like a copy, this is a PDF, I'll send it to you. I've got a piece of paper here.
I can provide you with everybody's email address.
Okay, great. And the other thing is, well, when I send it to you as a PDF, I'm gonna tell you how to go find it in Dropbox. Because the damn thing's like 200 megabytes. And the other thing is, where you work, right? Let's say, what do you guys work at Honeywell? Or Jabil, right? Great companies. And they'd like to have a guy like me come in,